Hello everybody, welcome back to part 3 of our 3-part import CSV series. Now today we're going to talk about 3 methods to import CSV data into Python. Now this part is going to talk about the Berkeley Data Science Library and the Pandas library. Now this Jupyter Notebook, as I said, is the third and final part of our 3-part series on how to import a CSV data file into Python. One thing that you guys got to know is that we're going to use a single command from 2 different data science libraries, and those 2 are the Berkeley Data Science Library. As you can tell by its name, it was created by the University of California at Berkeley. And then the second one is the Pandas library. Pandas stands for Python Data Analysis. Now, when CSV data is imported into Python, either using one of these libraries, the data will be presented and manipulated both on a column-by-column basis or/and a row-by-row basis. So it's either column-by-column basis and a row-by-row basis, or it's either or. Now, as this notebook will demonstrate, this is one of the great benefits of using these data science libraries. These libraries are very, very helpful and will make your life 1,000 times easier. And they're also very important and significant in data science, but also in programming as a whole. Now, let's make this theory come to life with hands-on learning. So we're here importing CSV data with the Berkeley Data Science Library. So here, let's start with the Berkeley Data Science Library. So we're going to do from data science import table. Now what this does is these 2 are keywords, as you guys can tell from previous notebooks, is when a word is dark green like this, that means it's a keyword. So we're saying from data science, so from the data science module, import table. Now we could say import data science, but we don't want the whole module. We just want a part of that module, and the part of the module we want is table. So we only want a subset of the entire module. And then here we're assigning it to the variable BDF, and the table we're doing table.readTable, and then the name of the CSV file. So read underscore table, as you can say, it's a method because it's light blue and it's followed by parentheses, and it's saying read table, read this data and make it into a table, and then we're assigning it to the variable BDF. So shift enter, and then wow, we see our CSV file is in Python. Isn't this beautiful? And wasn't that unbelievably simple? So it was very simple, and it gave us a 2-column, 9-row table. Now, unlike our CSV.reader method from Notebook 2, this did not return the first row in our table. It returned all of column 1. So let's do it right here. So instead of, what we're doing is BDF, the name of the table, and then index 0. So here, shift enter, and it gives us everything in this array right here. Every single thing in this column. So instead of it doing by a row basis, for the first notebook, it would just give us this first row. But in this table, it's going to give us this whole column right here. So it gives us the first column. Instead of giving us the first row, it gives us the first column. And that's what it did. It excluded the header, the name, and it just gave us all the data in this first column. Now for the same thing here, it's going to do the exact same thing. Now again, unlike our CSV.reader method from the second notebook, this did not return the second row in our table. It returned all of column 2. So instead of returning the second row, it just returned the second column, and that's what it did. It gave us all the data in the second column. And it says it's an array because it is an array. An array, as you can tell, if it has a square bracket and a parentheses. So that's the syntax and format for an array. Now, let me uncomment this, and we'll take a look at this in greater depth. So we're saying type BDF 0, so it's going to give us the column. Now it's saying it's a NumPy array. So you can see that this first column is a NumPy n-dimensional array, or ND array for short. Now, when we do BDF 0, 0, so it's going to say the first column, so here, and then the first object, which is this object right here, and that is a string, so it should give us type string. Or no, it didn't give us type string because we didn't say type. If we do type here, then it will give us string. Boom, it's a NumPy string. But since we didn't do that, it's going to give us the variable. Or it's going to give us what resides there, and that's what resides there. Now, like we said, we do type, and it's a string. It's a NumPy string, same thing as a string. Type BDF1, NumPy array, same thing because that's the second column. So in the second column, the first object in the second column is 99, and then that is an integer. Boom, NumPy int. So unlike the first two methods we used to import CSV data into Python, this method did not convert numbers into strings. This method of importing CSV data into Python retained the numeric data type. Now this is going to be very important because we don't have to change it from a string to an integer or from a string to a float. It automatically does it for us, which makes life a lot easier. Now, let's import NumPy and perform some quick statistical analysis on our CSV data. Now, NumPy is also a library, and it's very, very helpful, and you'll see it in just a second. So we're going to import NumPy as NP. So we're importing the NumPy module, and we're giving it an abbreviation NP. And then we're doing bdf.stats, so it's saying give us the stats, and then give us the stats for the minimum, maximum, mean, median, and standard deviation. Our previous two notebooks had absolutely none of these capabilities. As you will see in several DS4HS notebooks, the relationship between NumPy and Berkeley Data Science is very close. So we do that, and it gives us the stat for that table. And it says the minimum value was 57 for the heart rate, the maximum was 107. The mean heart rate or the average heart rate was 79.333 repeating. The median, so the middle number was 70 and the standard deviation was 18. So it gives us a nice clear statistical analysis on our data. Now let's import CSV data with pandas. So it's very, very similar as importing it compared to the data science module, the one created by Berkeley, the Berkeley Data Science module. So we're importing pandas as PD. Just a little abbreviation, and then we're calling it df for data frame equals pd. So for Berkeley, we imported for the Berkeley Data Science module, we imported the table from data science. We add table here to put the name, and we did dot read table. So here it's pandas dot read CSV, and then the same syntax. So it's very, very common or very, very similar to the Berkeley Data Science. And when we did shift enter, boom, it gives us these clean rows, but it also gives us the index number as well. Now we're going to show us this method that shows us the first 5 rows of data. So we're doing df.head, and it shows us the first 5 rows. And then we're going to do another one that shows us the last 5 rows. And if that's head, then you can guess it. Tails is going to show us the last 5 rows. Boom, and that's exactly what it does. Now let's use this pandas describe method to obtain insights on our imported CSV data. So this describe method is just going to give us a quick statistical analysis of our data. Shift enter, and that's exactly what it does. It counts the heart rate. It gives us the mean, standard deviation, minimum. 25% is below 67. Has 25% of the data has a heart rate below 67. 50% of the data has a heart rate below 70. 75% has heart rate below 99, and the maximum data is 107. Now, in this lesson, we exhibited the simple and powerful method of importing CSV data using the world's 2 leading Python data science libraries. Now, these data science libraries are very, very important. It's the Berkeley Data Science Library, also known as the Data Science Library, and Pandas, and the Pandas Data Science Library, or just known as the Pandas Library or Pandas. As we saw in this notebook, both of these notebooks provide column by column as well as row by row methods of analysis. Having both of these options provides for powerful column-based numeric analysis as exhibited by the Berkeley.stats Python method and the Pandas.describe Python method. In our next notebook, we will closely examine the Python library used under the hood with both the Berkeley Data Science Library and Pandas, the powerful NumPy library. So this is going to be very, very important. The Berkeley Data Science Library, Pandas library, and the NumPy library are all super duper important in data science. And guys, I know this can be confusing, but stick with it. Go back in the videos if you need it, slow it down, pause the videos, whatever you need. Email us with questions. But yeah, just go at your own pace, don't feel rushed, and you'll get the hang of it. And once you do, you'll be an empowered data scientist. And you'll be able to conquer the world of not just data science, but also programming. And as you guys know, this remote desktop is open 24/7. It's got really cool features. See right here, it's like your own desktop. Sorry, I have all these windows open, but it's like your own desktop right here. Wow, I have a lot of windows open, but I'm showing you right here. It's your own desktop, so you have so many applications. Here, you have a browser. Here are all my browser tabs. So I can literally, here's pypy.org, show me all the Python packages, but I can literally do whatever I want. Python videos, you have your own working browser right here. You also have your own terminal as well. So you have your own terminal where you can do whatever you want. Your own Linux terminal. You have everything you need, and you also have your Jupyter notebooks, your Jupyter Labs, all set up right here in your remote desktop. Like I said, it's always open, it's always available to use, and it's a really, really great tool. And in order to get good at programming, you need to practice, practice, practice. Like I said, if you guys have any questions, please let us know. Thank you so much.